All right, sketch the graph of the function y equals cosine x and y equals x squared with x between 0 and pi over 2. By the way, could you please in the chat just type your name sort of as a rule? You could do that, please. Okay, so cosine x, all right, now there is an issue of whether I'm going to make this to scale, and I don't think I am. I'm not going to make the axis, the x and y axis to scale, which is pretty commonly the case. Okay, so I'm going to, cosine is a wave function. I start at 1, and the maximum is 1, the minimum is -1. So here I have 2 pi. It's not to scale because pi is around 3, so 2 times pi would be around 6, and so these aren't to scale here. But I wanted to use the graph paper. Although maybe I shouldn't even do that actually, because I have to do y equals x squared. Oh, okay, it's okay. So the thing is that this is pi. So pi over 2 is around, pi is around 3.14. I think we all know that. So pi over 2 is around 1.5, 3 halves, 1.5. So now when I do first of all, this is a super easy graph to draw. It's just when I have the graph paper, I start trying to make it perfect or something. But this is essentially what it looks like, something like this. Okay, so this point here is supposed to be 1, 1. But okay, we have those two graphs, right? The point here is, and actually I'm only looking for between 0 and pi over 2. So I'm only looking at this part right here, and this other part here. The point is that they do intersect each other, and they intersect at some point. So the picture shows me there's an intersection. What I want to do is I want to use the intermediate value theorem to verify something that we see already, that they do have an intersection. They do have a solution, that x squared does equal cosine x. Okay, so I'm going to use the intermediate value theorem to show that there is a solution to x squared equals cosine x. The picture shows that anyway. Okay, so I want you to do this by following these steps. I first bring everything over to the left-hand side. So bring everything to the left. And so then I'm going to let f of x equal x squared minus cosine x. And then I'm going to make a note. I'll put bullets here. F is continuous on this interval. Because is a combination of a polynomial and trig function. So that's why it's continuous. We should say that. Next, I'll calculate f of 0. So I'm going to calculate f at the endpoint. That's 0 squared minus cosine 0, which is -1. Well, 0 minus 1, which is 0 minus 1, which is equal to -1. All right, so to remind ourselves that cosine of 0 is equal to 0, what we can do is we can draw a unit circle. And then at 0, I have 1, 0. And so, sort of messy. Oh, well, usually write it up here. 1, 0. Okay. All right, so remember, cosine's the x coordinate. All right, then at f of pi over 2, f of pi over 2, I have pi over 2 squared. I don't think I need to use a calculator to say, well, pi over 2 squared is around 3/2. I don't even think I need to know that, because it's minus cosine pi over 2, and cosine pi over 2 is 0. Okay, pi over 2, we have 0, 1, and cosine is the x coordinate. I mean, it's sort of squished in there, but okay. Let's do our best here. Okay, we see that f of 0 is less than 0, and f of pi over 2 is greater than 0. Therefore, there exists a number c. C is between 0 and pi over 2. C is going to be an x value such that f of c is equal to 0. Okay, now I am going to grab some more space here. I just want to put a little bit more in here. The last line. That is c squared minus cosine c equals 0. C squared equals cosine c. That's the end of the proof. Are there any questions about all that? I mean, this part B, there's homework problems. I put that on, talked about that in class. I added a little extra where you sketch the graph. I mean, what does it mean that x squared equals cosine x? It means the graphs intersect. And it turns out that there is no, like formula or way or something to find that point of intersection. But we can approximate that, and we can show that exists. But so, okay, any questions then?